Hey guys, so in this video lesson, we'll be looking at how the electronic structure of different atoms of different elements varies, what does it depend on? And we'll start off with first recapping what we know from O levels. What we know from O levels is the fact that when chemical reactions take place, that the electrons in the outer shells or the outer parts of the atom are the ones that are redistributed. Some atoms end up losing those outermost electrons, some atoms end up gaining some more electrons in the outer parts of the atom, and in some cases these outer bound electrons are shared, the ones that lie on the outer periphery of the atom. Okay, like I said, the electrons will be transferred from one to the other or just shared. And when a chemical reaction takes place, protons and neutrons remain unchanged. So the only thing that changes in a chemical reaction is electrons are exchanged. Now, that's the stuff we know of. We also know of how the atom electrons are arranged in an atom in a very simplistic theory called the Bohr model of an atom. It is the idea based on Niels Bohr, a Danish scientist, and the Bohr model of the atom discusses the electrons and their arrangement in an atom. So you probably have seen something like this already from O levels. This is basically a representation of the Bohr model of an atom, where there's a dense nucleus in the center and electrons are in shells around the nucleus. We call those electron shells, and each shell can contain a maximum number of certain amount of electrons. The first shell, for example, contains 2 electrons. We know the second shell contains up to 8 electrons. The third shell can contain up to 18 electrons. And as the electrons move further away from the nucleus, we tend to say their energy increases as the electrons move further away from the nucleus. This is the basic idea of the Bohr model. It was the model that you were using in O levels or IGCSE, where the electrons were arranged in shells. And as far as shells are concerned, we know that certain shells have a certain maximum, and the rule or the formula that we had learned to determine the maximum number of electrons in a shell was given by the formula 2n squared, where in the first shell we have discovered that there are only 2 electrons. The second shell we know there are a maximum of 8. The third shell we know can take a maximum of 18. And the fourth shell contains 32. Now these are observations made. There is no theoretical reason why. I mean, we can tend to explain to you why some of this happens, but again, these are observations we have made. And so this is stuff that you already should be taking away from O levels that you've learned before. The fact that there are atoms have multiple shells. Each shell has a certain maximum number of electrons, and as the shells move away from the nucleus, their energy increases. So this is the idea of the number of electrons in shells. Now I want to show you some arrangement of electrons in some basic elements that you might remember from O levels and IGCSE. Okay, so this table is basically the first 3 elements of the periodic table: hydrogen, helium, and lithium. And their proton numbers are 1, 2, and 3. And we know that there is only 1 electron in the outermost shell for helium, only 1 shell for hydrogen, sorry. Helium has 2 electrons because that's the number of protons it has, and both of them are on the same shell. For lithium, when you have 3, 2 go in the first shell, and that's the maximum number it can go, and then 1 goes in the second shell. And this can be written as a configuration of 2, 1. And that's how we tend to summarize or write configuration of elements. Let me show you some more atoms. Now here are 2 more atoms: carbon, sulfur. Carbon has 6 electrons in the atom. 2 go in the first shell, 4 go in the second shell, written as 2, 4. Sulfur has in fact 16 electrons. 2 go in the first shell, then 8 in the second shell, and 6 in the outermost shell, written as 2, 8, 6. And that's the kind of stuff we have. I could show you some more elements and their electron clouds, just as a recap of, hey, if you remember this from O levels, yeah, that, yes, okay. So let me show you some more elements. I'm going to scroll down now, and stuff like this. Now, these are some more atoms that we are studying. Let me just zoom out a little bit. Okay, so hydrogen has a proton number of 1. Lithium has 3, so 1 in the inner shell, For lithium, 3, 2 in the inner shell and 1 in the outermost. So it's 2, 1. Sodium is 11 electrons. Proton number is 11, which means that it has 2 in the first shell, 8 in the second, and 1 in the third. In the same period, you got argon, which has got 18 electrons because its proton number is 18. And argon is a noble gas. And its configuration is 2, 8, and 8. We call this the octet, if you remember that. And potassium, even though we knew that the third shell can take 8, but what we had learned for and discovered that potassium with 19 electrons, it isn't going to be 2, 8, and 9, but it is 2, 8, 8, and 1. And sometime in this chapter, you'll understand why potassium was 2881 and not 289, even though the third shell can take more than 8 electrons. And that's just some of the elements. From O levels, you also study the first 20 elements and their electron configuration and their reactivity and all that stuff. So let me show that to you right now. I'm going to show you the table for the first 20 elements. The table showing the electron distribution, starting from hydrogen, helium, all the way, that's period 2, then period 3, and the first 2 elements of period 4, from 1 till 20. From 1 is 1, 2, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and the second shell fills up till 8, and then the third shell starts filling up 1, 2, 3, 4, 5, 6, 7, 8. Even though the third shell can have more than 8, it becomes the fourth shell fills up with 1 and 2. And this is the kind of stuff you'll learn from an IGC or O levels. So this is all that you already know of. I'm just recapping so that we are all at the same place when we look at newer material. Now that's the configuration for atoms. We will also be able to talk about the basic configuration for ions before we look at more detailed reasons why we know we have shells. So let me show you some configuration for ions that you also should have known from O levels or IGCSE. So when we come to ions, we know we've got cations and anions. And when ions are formed, the electrons gained or lost are readjusted from the outermost shell. So if electrons are lost by some atoms, they are lost from the outermost shell. And when the atoms gain electrons, they are accommodated in the outermost shell also. Here are some examples of such. For example, nitrogen's ion is nitride. It's 3 minus. So when it gains 3 electrons, it goes from 3,5 to 2,5 to 2,8. When oxygen gains 2 electrons, it goes from 2,6 to 2,8. When sodium loses 1 electron, it goes from 2,8,1 to 2,8. And calcium, which is 2,8,8,2 as an atom, when it becomes an ion, it loses the outermost. So for example, nitrogen to nitride is basically gaining 3 electrons. It goes from 2,5 to become 2,8. When oxygen, which is 2,6, gains 2 electrons, it becomes an oxide, which is 2,8 also. And when sodium, which is 2,8,1 with 13 proton number, is going to lose 1 mole of electrons, it becomes a 1 electron for each atom. It becomes 2 and 8. And lastly, you got calcium. And calcium is 20 electrons. So calcium has got 20 electrons in the atom. But when it loses 2 of these electrons, it becomes calcium 2 plus 2, 8, and 8. And their configuration literally is identical to noble gas configurations. For example, all these 3 have the same configuration as neon. And this guy has the same configuration as argon. Let me show you the dot and cross diagrams also so you understand that. So like when sodium loses the outermost electron, it's got 2, 8 left in the shell. So the outermost 1 electron is gone. Now it's got 2 and 8, just like neon has a plus charge. When oxygen gains 2 electrons, its 2, 6 becomes 2, 8. It's gained these 2 electrons. The crosses mark them there as different electrons, or they're the additional electrons that came and not the original 6 from the oxygen in the outermost shell. So this is how we draw the dot and cross for ions also. So this was just a recap of what you guys know from O levels. In the next lesson, I'm going to talk about how we know that there are shells. How did we prove the fact that there were 3 shells in sodium atom and not just 1 layer of electrons? And for that, we have to understand the ideas of ionization energy. So that's coming in the next lesson. All right.